Welcome back, physics fans. This is our projectile package for Physics 11. We're on page, don't know what page we're on. We're on page 8. And we're doing question number 14. So let's continue on here. A car drives off a cliff of 60.025, right down to the millimeter. 60.025, and that's how far down it'll go. And it lands 70 meters from the base. Well, this is different. How long is it in the air for? Do we have enough information? Again, we do. It's horizontal, and the acceleration is 9.8 meters per second squared down. And with this amount of information, we can get the time through that. T is equal to the square root of 2d over a. But again, that only occurs, and let's just highlight it yellow, just put that emphasis, this only can be done if this is 0. And we'll do the square root of 2 times 60.025, all divided by 9.8. And see how this is. Square root 2 times 60.025 divided by 9.8. 3.5 exactly. I guess that's why Mr. Curl put in 5 sig figs there, just so you can get an exact number here. What's the final vertical velocity? That's what we're asked for here. That'll be VF is equal to VI plus AT, if you want, which will be, let's do in the order. This would be 9.8 times 3.5, which will be 34.4, but okay, 9.8 times 3.5, 34.3, I was close. But if we wanted to do it the other way, without calculating, without using the time we just did, it'd be the square root of VI squared plus 2AD. And that would be the square root of 2 times A times D. So the square root of 2 times 9.8 times the height of 60.025. Well, same number. 34.3 meters per second down. What's the horizontal speed? It took 3.5 seconds, and this is 34.3 down. The speed, V is equal to D over T. V is equal to D over T. The distance it traveled is 70 in 3.5 seconds. I think that's about 20. 70 divided by 3.5. 20 meters per second. And then what is his impact velocity? There we go. We have the 20 this way and 34.3 this way. We then have to draw our hypotenuse, and that would be V is equal to the square root of 20 squared plus 34.3 squared. And theta would equal the inverse tan of 34.3 divided by that 20. Let's just do that in one time with the calculator here. The square root of 20 squared plus 34.3 squared, and then inverse tan of the 34.3 divided by the 20. There's our numbers. This is going to be 39.71, and this angle here is 59.75. So we put them together, get rid of the calculator, to say that the vector velocity is 39.71 meters per second at an angle of 59.75 degrees BTH. And look, I'm just copying it out from there, it looks like. Okay, now to go to question 15, which is going to be a small curveball. And if you hated math, it will be a little bit larger of a curveball. Pun intended, projectiles, curveball? No. A projectile is launched at 40 meters per second at an angle of 60 degrees. So the initial speed is 40 this way at an angle of 60 degrees. It's above the horizontal. What is the initial horizontal speed? So we want to calculate this. And what's the initial vertical speed? We want to calculate that. Because it's going up and it's going horizontally. And this is just the reverse of what we've been doing. Beforehand, we've been doing Pythagoras and tan to get the hypotenuse and the angle. Now we're going to calculate the x and the y. And if you always draw it with the above the horizontal, this is always going to be the hypotenuse times the sine of the angle. And this is always going to be the hypotenuse times the cosine of the angle. But if you want to remember it, that's so ka toa. And let's do the vertical. No, let's do the horizontal. The horizontal is asked first. So the horizontal is what we're going to show that that's how we get it. And why do we go there? Because we have the hypotenuse and the angle, and we want the adjacent. So we want the adjacent. We have the hypotenuse and the angle. So we use the cosine. So the cos of 60 is equal to the adjacent over the hypotenuse, which is 40. So we bring up the 40, and we get 40 cosine 60 equals the adjacent, and that's what I wrote down here. And similarly, the sine of 60 degrees is going to be the opposite over 40, and you bring up the 40 there, and that'll be the opposite, which is that. This is just a quick review of it, and if you just remember that the sine is always for the y and the cosine is always for the x, alphabetical, x, y, or c and s, however you want to do it, pull up the calculator. Let's do both calculations in a row here. 40 sine 60 and 40 cosine 60. Okay, and this is exactly 20 meters per second, and that will be horizontally. And this will be 34.64, excuse me, meters, not degrees, whoops, meters per second, and that will be straight up. Okay, thank you. And now let's try it. We're probably going to be launching projectiles at angles now and this is where it starts getting a little screwy. I'm glad you got this far and understanding it, I hope. All right, excellent. See you next question.